We're going to get started with deploying web apps to Azure using CI/CD and Azure DevOps. My name is Alan Conway. I'm a principal consultant at Zebia in the Microsoft services line, doing all things related to consulting through app dev, Azure, AI enablement. I have about 25 years of experience exclusively as a software engineer and consultant, a bunch of contact information, how to get a hold of me. Pretty much if it's Alan Conway, you got me, with the exception of the YouTube channel, the Eclectic Dev. So that's pretty cool too. And also a MVP in .NET and web. So I love this technology. Now, just a quick level set on this. This fast focus is really app dev or software development focused from that background. So maybe developers who are living in a click ops today or manually deploying and want something that's more repeatable. I'm keeping the scope intentionally practical and introductory. So if you're already deep into Terraform and provisioning and policy enforcement and networking and governments, this is probably a little bit rudimentary for you. But for the rest of the folks, again, that target audience is, are you manually deploying or doing things the hard way? Listen, I work in the real world too, depending on the size of the shop, what the team dynamic. This has evolved into a career onto its own. So a lot of places might have excellent software being built with great architecture and such, but getting it out to the cloud or to wherever that is kind of an afterthought. So even though this is a little bit tongue in cheek, it really is kind of the way that some way of deploying software from, shooting straight from the hip. As a developer, maybe you right click and publish from one of the different IDEs. Maybe you click ops, you go to the portal and you set everything up. For small applications, it works, but it can be a fragile process. Today, we need continuous integration, deployments, that awesome code that you're writing, getting out into the different various testing environments and production seamlessly is a lot less work, believe it or not, once it's been done and the infrastructure's been built up, than actually having to manually deploy it. And then if you go on vacation, somebody's like, how did you do that thing? And our app service isn't running the way it wants and things like that. So this is the idea, is that we're moving from that very manual process to something that's more scalable. And again, we, as mostly those of us that are software engineer backgrounds, write code, app development, a big portion of our community, maybe 5, 10, 15 years, it's different for everybody, veered off into another domain where their expertise now lies. They spend a lot of time writing Terraform and infrastructure as code and cloud provisioning and security and networking. It's like what IT was, and then becoming a software technologist around that. But those of us that have kind of stayed in app dev maybe didn't venture into that. So we need to understand some of these things. So what are some of the provisioning options that may have been used? Again, the Azure portal. It's great for learning. It's great for visual. And you can see something very quickly and provision, but it's not scalable, because if something happens to those resources or whatever's been created in Azure, it has to be done again and again through the portal. And so it's again, a great way to learn and get up to speed, but not necessarily the production method of deploying your applications. That next layer is like scripting, PowerShell, the Azure CLI. Now we're getting some repeatability at least. You have a script that might provision your website, your web app to Azure, but the problem is if it crashes halfway during, it may not understand the state. It's more fragile from that standpoint. It's not idempotent as the last option is, which is known as infrastructure as code, or IAC, which is often called, where in a declarative way, you don't tell it how it's doing, like the scripting, like where it's like, create this and do this. You're just saying, I need an app service plan, and I need an app service, and I need log analytics workspace and those types of things. But you're not telling Azure how to do it. That's declarative programming via templates, and we'll look more at that. And that's what we want to do. So again, explain what you want, but not how to do it. We're defining what the end state should look like. The main downside to this is really the learning curve. Because again, are there any folks in here that have made a career out of infrastructure as code and that's their primary Okay, good. That means this is the right audience, because if you were, this would be too rudimentary for you. So this is, something again that you can, what the goal here is that you want to be able to understand enough and be powerful enough to move from those very manual process to something that is repeatable, and trying to show, even though I have a compressed amount of time, that to bridge that gap and that learning curve may not be as difficult as one thinks. Especially, let's be realistic, it's 2026 with GitHub Copilot, and our aid and AI development can definitely help us. So again, the infrastructure as code is also committed as part of your source control. So I have a demo app here, and that is a part of it. Now, in some more sophisticated solutions, they may be their own repos and such. Remember, I'm showing kind of that first on-ramp. That's the intended piece here, versus some of the different layers that may end up happening over time. Faster business value, because when you're committing code and it gets integrated, it's going to automatically get deployed, built and deployed out to the different environments that you have provisioned based on how you set up your infrastructure. And again, that old workflow of manually deploying code, even if it worked, it's fragile. Maybe only a certain person knows that code or that process. I go here, I run this one script, then I go to the portal and do these settings. I go back, I run this script, and I wrote a README. That's not really an efficient way, but I understand that's the real world, and sometimes that's how it happens. So we want to kind of get to that next step where we can have idempotent delivery. And what does that mean? Like, I can take, when I've completed this, I can take all of my environment, it could get corrupted, deleted, moved, change subscriptions or whatever, and my infrastructure as code, once it gets, run, reapplied again, and something is built and provisioned out in that environment, it will do it all over again. And it's nice too, because if some of those resources and objects already exist out in Azure, if it already exists, it won't recreate them. It just makes sure it's in the right way that it's been declared in your templates, and then it will move on. So whether part of it got corrupted, some of it deleted, the whole thing, it changed, this is that capability to do it over and over, and expecting the same output, that the given state that we've written in our infrastructure as code. So what kind of environment or technology, and this is not an exhaustive list, but we have a pipeline. That's what's going to build our application, package it up, and then deploy it. And then it's also going to say, hey, infrastructure as code template, run now. And then that's saying, I need the app service, I need this and that. So all that will happen together between the pipeline coordinating. In this case, we're going to talk more about it, but we would use, just for today's sample, because it's introductory, ARM. Most people don't use ARM templates. We'll talk about it in a minute. Like, because it's lower level, there are other ones to use, suggested alternatives like Bicep, which will transpile into ARM templates. It's a little easier to write and read. And then if you're really going another step, which is beyond today, but something like Terraform, that's cloud agnostic, I'm focusing on Azure. The environments might be this Visual Studio Code. You might be writing the code. You could have GitHub Actions that actually run your pipeline. Azure DevOps, that's what I'll be using today. Azure itself, the Azure CLI, if you were working with that. So the Azure Resource Manager, or ARM, it's Azure's control plane for provisioning and managing resources. The ARM templates, which I'll show in a minute, are the native JSON deployment format it processes. And I mentioned, and I'll talk about Bicep, it's a cleaner language that compiles down to that format. The bigger takeaway from this is that infrastructure becomes declarative, repeatable, and source control. So we will work with the Azure Resource Manager via our ARM templates. So the ARM template code, there's a bunch of ways to get started with it. Some of these may be growing long in the tooth, even though they're valid, like create a custom template, look for open source templates, PowerShell commands, Resource Explorer, export it from the portal. But again, in the era of AI coding assistant, I would probably say, start me out with a pipeline. And here's what I'm going to be using. I'm going to be using, Azure DevOps or GitHub Actions, and I want to build this Blazor app or this Angular app or whatever you're doing, and it needs to be this version. We're using .NET 10, so make sure it builds the right version and all of those different things. Those can all be specified in the build pipeline. And then in the ARM template code itself, that's the provisioning for Azure. That's I need my Azure app service plan, the app service. I'm going to use development slots. I'm going to have log analytics and all those sorts of things, and you can dictate that within there. As mentioned, Bicep, and I'll show both here in a minute, it's a little bit easier to write and to understand. So if you were targeting Azure and doing this first step, you probably are writing Bicep. Again, today's not about ARM versus Bicep versus Terraform. It's just understanding that this can be done. And actually what ends up happening is, and I'll show the command, you transpile Bicep into the ARM templates that will ultimately get used by the Azure Resource Manager to provision those assets in there. Then we have Azure DevOps itself. Now we could be using GitHub if you were in that stack, because GitHub Actions will run our pipeline and do all of this. Or we could use Azure DevOps because a lot of teams are still working within that environment. So again, it's not a kind of either or, it's the capability that both could run your pipeline in there. And so within that, we have a view into how the pipeline's running. Did it build? Were there any errors or problems? Which environments did it provision to? So that's great to have that insight depending on where you're pushing this. And then again, my YAML pipeline. Now, there's a few different ways that you can, within Azure DevOps, do this. You can, what we ended up doing and what's done here is that the pipeline was, so I commit the pipeline to source, I go into Azure DevOps, I pick that YAML file, and then away we go. Now, the pipeline, as it shows, is wired up to my repository. So after a PR and something gets integrated into main, this pipeline runs. It gets the ARM template, checks the provisioning. Do I need to provision anything new? Is it out there? Yep, it's all good. And then the build finishes. So let's take a look at all of these different pieces. So I have an Angular app here. I'm not going to focus on the app itself, but just the pieces for what we're talking about today. So within this application, there is a folder so we have a couple of different folders here, and the one I'll be focusing on is this Azure folder. So let's start by looking at this pipeline, which is a YAML file. And so again, as I had mentioned, in this syntax, don't be intimidated by it because it's not that difficult to write. And also if you were assisting with Copilot, it could help you out. But the trigger is saying when something is integrated into the main branch, this pipeline is going to run. So this is a smaller app. So this PR gets integrated into main. Maybe it's the dev branch, whatever. You could have different versions of this. But it does not run on the pull request itself. But you could turn that on if needed. I have some parameters, and these take the shape of having some flexibility. I actually can toggle this pipeline to say either use the ARM files, which are right here, or use the Bicep files if I wanted to, because they're equivalent in what they declare. So you have parameters. You can change those parameters. Also, we have some variables here with the app service name, the app service resource group, the analytics resource group, what location, things that you would expect. And one of the nice things is here you can collapse all of these different stages and jobs, but we need to build my application. And again, if you're looking at this for the first time and going, that's why we never did it, because that syntax, I don't even know what the heck. Again, there are so many templates out there to get you off the blocks. What are we doing? We're doing a job to build the Angular web app. We're using, the specified node version. We have the npm install of Angular. If we were doing Blazor, this would be .NET build, .NET restore, making sure that everything is there and working. Then it flattens the build and it creates an output, an artifact. We need the files. And so we have the files, we copy them out, and once those are copied out, then we can publish that artifact to the drop folder. Now we want to provision Azure. So this is the pipeline. It's kind of like air traffic control. Build this, do that. Now let me call the provision file. So the provision Azure file first uses the Azure CLI to get a couple of resource groups set up. So if you're doing ClickOps, you're basically taking maybe what that process was and condensing it down into a declarative format here. This is the only step to make sure those resources exist first before the ARM template happens. So here's the Azure ARM template deploy, and it takes the app service JSON file, Azure App Service, that's the ARM template, and the parameters file, so for some flexibility. And then I have deployment slots. So I have dev, QA, staging, and production. Again, this is a demo example on a condensed layer, but it shows that it can, because I want my app service to have separate deployment slots. And whatever your target environment is, that's how you set it up. These are basically repeats of themselves. So if we look at the ARM template, now this code, again, it's going to work for, so you have some parameters that are provided. And in the parameters file, we have all those things like the SKU code and, what are the names that's being provisioned, what's the location, things that you would expect. And then within the ARM template file itself, I'm going to give me as much real estate as possible. We come down here, and again, you'll see these depends on, and so there's a little bit of an order that this file runs on. So the first thing it'll do is actually, it will create the resource group for the analytics, the log analytics and application insight. In unison, what it's going to do is create the app service plan. Those can happen in conjunction. The app service itself needs the app service plan. So that's what these depends on are for. And so once that step is completed, then it can create the website. And it creates it using those parameters like location or, which slot is it going to. This is all configurable. Now, this is a bit verbose. That's why there are other languages and technology stacks that make this a little bit easier. Typically, if you were going to work with raw ARM, you would start with a template and modify it. Looking at this same setup in Bicep, you're going to see it's quite a bit easier to read how it's set up here. So we have our parameters. Again, it's going to be doing the same declarative approach here. We have our log analytics, our app insights here. Then we have the hosting plan name. And, I've got Linux. What's the location? Again, that's a parameter that will be input. Once again, here's my parameters that I've dictated. And this will continue on. So here's the website. We also have the different settings that are required. And then we have the different deployment slots for this particular setup: develop, QA, staging, and prod. There is a command, if you were using Bicep, which is the one right here, that you can point it at a file and call AZ Bicep build, and that outputs the ARM template so that your pipeline can run it. If I move over to Azure DevOps, here is that YAML pipeline that I configured. So all I did was point it to my repo, and if I was to hit edit here, guess what you're going to see? You're going to see single sign-on. You're going to see the YAML code, the YAML pipeline. That's the code I just showed you that was in my repo. And so, yes, there are these tasks and helpers, and you can go down that path, but this is the most repeatable, and this is the ideal state we want to be in. Again, you get the green check marks. This pipeline is run. If I move over to Azure, here is my PWA weather app. I did not hand roll this. This went through that pipeline. If I was to go here and delete everything and do one build, all of this would get put back exactly as it was from those templates. And you can see here, there's the production, develop, QA, and staging. And then if I go out, here's my app, which is out there, which is a PWA weather app. And it's pretty hot outside right now, so I recommend staying in the air conditioning. That's it. That's a lot for 20 minutes. This could be easily, hour and a half day workshop if you're really getting into it. The takeaway is that I want just to, again, plan a nugget, just get you to see some of the building blocks that are necessary to get up and running and away from click ops or manual deployment. Take it in steps. Take that first level. Just get this declared. Your environment's provisioned. And then you can begin to iterate and scale once you have a better understanding of it. The last thing I'll say is you will quickly, if this is all new to you, get a lot of very deep enterprise platform engineering and DevOps. And if that's not your expertise, it's okay. Again, you can go in these iterative steps, get step one done, get it idempotent and deploying, and then move to that future state with a little bit of refactoring. Hopefully you all found this helpful, and I hope you have a great rest of your day here at VS Live. Thank you. Yeah, you come on.